Assalamu alaikum wa rahmatullahi wa barakatuh. Hello my dear students. Today I'm going to continue with you on this part of our lecture how to go through the remaining parts of functions, how to do graph, sketch it, and this was covered mainly in class work 1, and I'm also going to continue on class work 2. He is asking you here to give a general behavior of this function. If you remember, y equal x squared plus 1 divided by x plus 1. Once he asks you this question, and this is one of the very important questions that you should study, and I believe that you should solve one of these problems. You have a lot of them, so please try to solve these problems. Mainly when an example of these problems and so on. When he asks you about this, the problem is separated into 3 parts. The first of them is to identify, from my point of view, is to first identify the various similitudes related to this problem. Part number 2, try to find the critical points, the maximum, the minimum points. Number 3, try to give a sketch for this function. So, first of all, I will start with the identifying the various asymptotes for this problem. The first and simplest type of asymptotes that you can find for any problem is to try to find your vertical asymptote. So, once we need to find the vertical asymptote, it's very, very simple. All I have to do is to answer this question. Limit x tends to which number that will enforce this problem, x squared plus 1 over x plus 1, to tend to infinity. If you have exponential functions, you should try to, so it will make no difference in such a problem, but you will have to search for the value that will oblique your function to be infinity. In such a case, just finding the value that will that your denominator will equal to 0. This is going to be the value of your vertical asymptote, which is simply at x equal to -1. So now we have a vertical asymptote at x equal -1. In fact, yes, exactly. If you try to substitute by -1, you will end up having your denominator equal to 0. So we have a vertical asymptote at x equal -1. In a similar manner, I will try to find an inclined or horizontal asymptote. So I'm searching now for inclined asymptote or horizontal asymptote, which is simply can be a part of this equation, y equal to ax plus b. In order to identify the value of e, you will have to get the limit of x tends to infinity of f of x divided by x. This is correct for most functions, but if you have exponential function, you should do it twice. Once when x tends to positive infinity, and then you will have for the right side of the x-axis, then you should do it once more when x tends to negative infinity for the left hand of your x-axis. If I want to substitute here in order to find the value of a, it's really very simple. All I have to do is to just go through limit x tends to infinity f of x. I will replace x squared plus 1 divided by x times x plus 1, and this is going to be simply x squared plus 1 divided by x squared plus x. Taking limit x tends to infinity, we can do it either way by dividing both the denominator or the denominator on x squared, or simply apply L'Hopital. Once you have infinity by infinity, we can use L'Hopital method in order to find the value of this function. That's gonna be 2 over x divided by 2 over x, limit x tends to infinity. Another derivative, or just simply try to simplify this numerator and the denominator, you will end up having e equal to 1. Once a appears, that means we don't have horizontal asymptote. We have just only an inclined asymptote. Now I will try to get the value of b, which is simply limit x tends to infinity for f of x minus a times x. Please try to write the laws. Please try to write the laws. Once you write the law, then you try to substitute in it. It's one of the vital steps in solving any problems, and it's a defense, it's a self-defense strategy for you. If you have any problem or you make any mistake, I can find something to give you, to grade you. At least you understand how to use or which law you can use in this situation. So please don't miss to write the laws required for each part. Now I'm going to substitute here in this problem. So limit x tends to positive infinity. I will replace f of x by x squared plus 1 divided by x plus 1 minus a, which is 1 simply, times x. I will have to simplify this problem a little bit in order to be able to use the various methods of the limits. So simply it's going to be limit x tends to positive infinity, get a common denominator for these two parts, which is simply going to be x squared plus 1 minus x times x plus 1, and you will end up having, this is x squared minus x squared, they will cancel each other. You will have 1 minus x divided by 1 plus x. This is the limit of x tends to infinity. Divide both the denominator and the denominator on x, or try to differentiate both of them separately using L'Hopital. You will end up having -1, and this way b equal to -1, and you will have an inclined asymptote at y equal to a, which is 1 times x, then b, which is -1. This is your inclined asymptote. And don't forget that you have a vertical asymptote, which is simply at x equal -1. If you have this information is really very sufficient for you to give a sketch for this function, to speculate how it's gonna this function is, even before you get your critical points. We'll show it to you. It's really very simple. Okay, so this is mainly the main steps, so you have to review them. Please do review these steps. Let me try to give you the sketch, and I will go to the critical points, which is, just a second. Okay, I'm sorry. Okay. Let's start this screen. Guys, it's really very simple that you can solve your problem easily using the techniques that we did go through. Find first the vertical asymptote, then your inclined asymptotes, then try to speculate where is the function is going to be. It's usually the function or the graph is going to be between your asymptotes. So simply, if you write your asymptotes and you know, if you sketch your asymptotes and you know the areas in which your plan is divided to, so it's going to be really simply or simple to identify where your function is. Just give me seconds, please. Okay, let's choose the right source here. Okay, perfect. As I told you once more, we already know that the asymptotes, okay, are y. The asymptotes were at x equal to -1, which is a vertical asymptote, and we have our inclined asymptote, which was y equal x -1. All I have to do is to try to sketch the function. First of all, try to plot your asymptotes at x equal -1. So I have an asymptote over here, which is gonna be at x equal -1. Then I want to sketch y, which is equal to x minus 1. It's an inclined number. I'm sorry, it's an inclined straight line. So inserting x equal to 0, y is going to equal to -1. And if we put y equal to 0, x is going to equal to +1. So this is the inclined asymptote. So now we have a vertical asymptote at x equal to -1, and we also have an inclined asymptote at y equal to x minus 1. This is the inclined and this is the vertical asymptote. All I have to do is to speculate where the function is going to be. If your function is between these two lines, it will be quick to just to walk between them or to move between them, but it will never intersect any of these lines. If it was under the inclined asymptote, it will also have to move beside your inclined asymptote. So simply, I will take a number to the right and the number to the left from the vertical asymptote. The tempting number that appears with me is 0. Since it is to the right, it is a number to the right of -1. If we try to substitute with 0 with this line, you will end up having -1. So actually, it's at -1. Taking x equal to 0 and substituting on the main function will be +1, which now for sure your function is between these two lines, so the function will have to move like this. It will have to be within these two lines. Here you go. This is the function in this part. In a similar manner, I will try to just pick any number that's less than -1, let's say -2. I will need to see at -2 how much or what is the value of y for the inclined asymptote. So simply at -2, if we try to substitute at -2, you will have the function at -3. So let's take -2 and substitute in the main function. So it's going to be 4 plus 1, which is 5, divided by -1. So for the inclined asymptote, it's at -3. For the main function, it's at -5, so it's in here. So, and this is how the function will be in such a way. So this is the curve that you are seeking. This is the shape of your function. I've succeeded in sketching my function based on the inclined asymptote and the vertical asymptote only. I can write the domain simply. The domain, it's going to be x belongs to R except at -1. But if I want to find the range, I will have to first, it's going to be R except some region here. But I will have to get the values of these two vertices or these two crowns, which will appear from the critical point analysis. We already have the vertical asymptote, the inclined asymptote. We succeeded in sketching our curve. Now I will show you how to get your critical points. Really, you know that. It's really very simple. Okay. First of all, this is x squared plus 1 divided by x plus 1, as you can see. F dash x, I will get the derivative of this function, squaring the denominator. Getting the denominator, I'm sorry, getting the derivative of the denominator times the denominator. Then I will take the denominator equal to 0. I will get the critical points at the x values. I will take these 2 points and substitute in the main function to get the y values. Then I will get y double dash, the second derivative, inserting the critical points in y double dash in order to get, if it delivered a positive value, then you will have a minimum, local minimum point at x equal 0.41. And if it was negative value, you will have a maximum at x equal -2.41. I've known the maximum and the minimum. Remark, it makes sense actually. This is 0.41, which is actually on the right side with the graph, and this is for the other value which is negative 1 point something. This is the sketch actually after we draw the horizontal and the vertical asymptotes and your main function. Once more, please, if you have any problem regarding this part, please try to go through the method. It has a lot of problems solved in it, and you also in the PDF you have a lot of problems. For classwork 2, it was dedicated to cover mainly integration, definite integration application, numerical integration, the part with complex analysis, as we did go through. If I want to integrate these problems, it's really very simple. Most of you got the results right, but you will have to review integration. Integration is really, very important. So, if I try to see the first problem, he's giving you this form. It's an exponential function. Yes, stop. You remember, when I deal with exponential function, I have to remember its rule. Its rule states that if you have f dash x times e to the power of f of x with respect to x, it's simply, once this condition is satisfied, the result is going to be e to the power of f of x plus a constant. So all I have to do is to be sure that the derivative of 4x cubed plus 3x squared, which is simply 12 of x squared plus 6x, I have to be sure that this value already exists. Remarking the difference between the derivative and what exists, you will see that you are missing 6. So all I have to do is to rewrite my problem. I will multiply by 6, then I will divide by 1 over 6 for the function which is 2x squared plus x times e to the power of 4x cubed plus 3x squared plus 5. Start integrating. The condition is satisfied, so the result simply I is going to equal to e to the power of 4x cubed plus 3 over x squared plus 5 divided by 6. Don't forget to add the integration constant. If I went to the problem on the other side, wait, as I told you previously, once you have a numerator and a denominator, please try to look deeply to your denominator. The denominator here is x to the power of 3 plus 4 of x. There is a condition here, and remember also that the power is equal to 1, which refresh the main law that states once you are integrating f dash x divided by f of x, and you are integrating with respect to x, the integration is going to be really very simple. It's going to be ln 4f of x plus a constant of integration. This is going to happen if the condition is satisfied, that the derivative of f of x is already exists on the denominator. Once the denominator derivative is exist on the denominator, so it's a piece of cake. It's going to be the length of your denominator, and you will end up your problem like this. I will have to check the derivative of this function. The derivative of this function is simply 3 of x squared plus 4. But unfortunately, it does not exist. It does not exist on the denominator. But if we took 2 out of your denominator, it's going to be correct. So all I have to do is to state that I is going to equal to, I will take 2 as a common. The remaining of your denominator, it's going to come up to 3 over x squared plus 4 with respect to the x, which is divided simply on x cubed plus 4x. The denominator is the derivative of the denominator, so simply I is going to equal to 2 of ln x cubed plus 4 of x plus a constant, and you are done from this problem. Please do review the main laws of integration, then try to solve at least one problem on each law. You will find it really very easy to deal with. This was for the parts A or B in your first question. Question number 2 is giving you another 2 problems. Actually, one is very near to the previous one, but with just only one difference, which is, oh wait, I will have also to check, as I told you, you have to look at the denominator. Once you look at the denominator, you will find that the power is not equal to 1, so I can't use the previous law, but I will remark that the derivative of the denominator, which is simply going to be 4 over x cubed minus 4, which can be easily found on the denominator if you simply multiply by 4 and divide by 4. So all I have to do is to divide 1 over 4, multiply by 4, so it's a 4x cubed minus 4, which is simply divided by x power 4 minus 4 of x to the power of 3 with respect to the x. Here's the denominator is a derivative of a part of the denominator without the bar, so I will have to follow the law which states if you have f dash x times f of x to the power of n dx, the integration is going to be very simple, which is f of x to the power of n plus 1 divided by n plus 1 plus a constant. This is very simple. Don't forget that it can be written as 1 over 4 integrate 4x cubed minus 4 times x to the power of 4 minus 4 to the power of negative 3 with respect to the x. So I is going to be 1 over 4 x power 4 minus 4 of x. Don't you ever forget negative 2 plus a constant. Then divide by negative 2, so you will end up having negative 1 over 8, and this is the right answer for this problem. If I want to go to the second problem in this question, it's giving you also a numerator and the denominator, but there is a difference. The derivative of the denominator, it doesn't exist on the denominator simply. The derivative of your denominator is 4x to the power of 3. Not exist on the denominator, and you can't find it. And you can't find it. But, okay, listen. If I want to integrate, and this is 2x with respect to x, this is 1 plus x squared to the power of 2. This is the second trick I can use once I have a numerator and a denominator as we learn together. So all I need to check is that the derivative of the function inside the squared bracket, its derivative may exist, which is actually exist. This 2x really exists. So simply the integration for this function is going to be I, which is going to be 10 minus 1 of x squared plus a constant, and this is the function that we are dealing with, 10 minus 1 over x squared plus c. If I want to differentiate, it's going to be 1 over 1 plus x squared. Derivative of x squared, which is going to be 2x. It's the right solution, so it's really fine. So it's really very simple. All you have to do is to review your main questions or main laws, and then you will find everything written with you, and it's really very easy to follow. If you didn't study or go through your main functions or laws, it's not going to be arranged for you. And this is the main issue in integration. You have to organize your thinking in dealing with such problems, okay? Once more, okay, he is giving you another 2 problems, which is really very systematic problems. The first of them, you have 3x plus 4, and then try x. The other one is the root of 9 minus x squared. And for these problems, I believe you will need, for the first one, integration by parts. The second one, you will need substitution. If I want to deal with the first problem, it's really very simple. This is the first case on integration by parts. I will let the polynomial part to be differentiated, while the other part, which contains sin x, to be the integration for integration. Apply your law. I'm gonna integrate sin x which is simply gonna be sine of x times 3x plus 4 minus integrate. The function you already integrated, it will go as your integrand, getting 3x plus 4, which in derivative you will end up having positive 3. Finally, I will equal to 3x plus 4 times cosine of x. Then integrate this part, which is going to be negative 3 times sine x plus a constant. I've already completed and have the full mark for this problem. It will be very nice to state that this is integration by parts, and you may write the law of this, write the law of integration of by parts. If I want to second the problem, it's really a very simple one. I want to deal with the root of 9 minus x squared dx. And this is going to be really very easy if you use the right substitution. And you have substitutions like this, you should go through this idea. All I have to do is to let x equal to 3 of cosine t or sine t, whatever. This is going to develop dx will equal to negative 3 times sine t dt. Start making your substitution, and you will end up having the first replacing dx. So you will have negative 3 integration of a sine t times dt. You will have your square root. I will replace x by 3 cosine t. You will end up having 9 minus 9 cosine square t. Take 9 as a common, so it's going to be negative 9 square root for 1 minus cosine square t times sine t dt. Replace 1 minus cosine square t by sine square t under the square root. It will develop sine, so you will end up integrating sine square t with respect to dt, negative 9. Simply start replacing sine square t by 1 minus cosine 2t, so it's going to be negative 9 integration 1 minus cosine 2t divided by 2, and then integrate with respect to t. So it's going to be negative 9 over 2, open your bracket t, minus sine t plus a constant. If you would like to reverse your substitution, simply from this relation, start to get t as a function in x, which is simply gonna lead to t equal to x over 3 cosine minus 1. So I'm gonna replace every t by cosine minus 1 over x over 3, and this way you will have your final work. These problems are really very simple and direct. He's asking you to get the area enclosed by these two curves, verify the mean value, which is very, very important, and also he's giving you, he is asking you to evaluate this function, which is really very simple. If I want to integrate this function, it's very, very simple. Once you start remarking that this is an even function, so all I have to do is to integrate from 0 to 2 for 2x squared plus 4 dx, which is simply going to be 2x power 3 divided by 3 plus 4 of x. Start replacing every x by 2, then by 0. Don't forget to multiply by 2. If we do this, it's going to be 16 over 3. So we will end up having 16 over 3 plus 8, which is 24 over 3. I believe the right answer is going to be 80 over 3 for this problem. He's asking you about the mean value, and this is an important part. We did go through it. It's simply, once you need to find the mean value, which is mu, for a certain function within a certain interval, all I have to do is to substitute in this law, 1 divided by b minus a, integration from a to b for f of x times dx. And this is going to be simply equal to 1 by minus 0, integrate from 0 up to pi 4 sine square x dx. Start integrating, which is simply going to be 1 over pi, integrate from 0 to pi, replace sine square x by 1 minus cosine 2x divided by 2. Finish your integration and start substituting, and I believe the value is going to be 1/4. He's asking you about the area enclosed by y equal x squared, y plus x squared equal 4, and y equal to 0. This is really very simple. As you see, y will equal to 4 minus x squared, which is a parabola that's symmetric about the y-axis. You can either speculate the shape, or you can do it, or can simply remember in functions. We know that this type of a quadratic function simply can be drawn if you put it on the big form of y minus e equals some k of x minus e to the power of 2. And this function can be simply be y minus 4 equal negative of x minus 0 to the power of 2. That's gonna lead to, this is the y-axis, and this is your x-axis. Symmetry about the y-axis, I will have to go for the vertex, which is 0 and 4, at x equal to 0, y equal to 4. As you see, k is negative, so the curve will go down like this. I need to find the area enclosed by that curve and the x-axis, so simply I'm going to integrate with respect to the x, but I will need first to find the integration limits. And this can be easily done by solving this curve with y equal to 0, which is the x-axis. That will leave you with 0 equal 4 minus x squared, which is gonna happen simply when x squared equal positive 4, that's x equal to positive negative 2. This is negative 2, positive 2. I believe I will integrate the right part and multiply the area by 2, so simply I'm going to integrate from 0 to 2 times 2. The curve that we are dealing with, which is y equal 4 minus x squared, really very simple, 4 minus x squared with respect to the x. Start integrating, which is going to be 4x minus x to the power of 3 divided by 3. Then start substituting from 0 up to 2. Don't forget to times 2, and this way you will have the right answer for the area enclosed by the curve y equal x squared and y equal to 0. I will get the area of this part. Really very simple problem. Please try to solve some of these problems while studying for your final exam. Many steps, direct substitutions. All you have to do is to try to solve as much as possible. Practice, don't you forget. In mathematics, practice makes perfect. One of the major points is to find an integration for this function using the trapezoidal rule, which is really also a very simple problem to solve. All I have to do is to memorize that I will have to find h first, and this is stated that h equal to p minus a, the difference between the integration limits, divided by n, which is simply, divided by the number of points that you want to distribute your integration interval. So it's going to be 1 minus 0 over 10, simply going to be 0.1. Yes, I remember that the value of this integration is going to equal to h over 3. Oh, it's trapezoidal, I'm sorry. So you will have to review your trapezoidal and your Simpson rules. That if I want to evaluate this integration using trapezoidal rule, so simply it's going to be h over 2, open your bracket. It's going to be f at a plus f at b plus 2. What's in between these two values, which is going to be f a plus h times fa plus 2h plus blah 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 till you reach f at a plus 9h and so on. So simply, here's f of x is the function in the integrand. It's not an integrable function, which is 2 to the power of 3x squared. So all I have to do is to find the values. So it's gonna be 0.1 divided by 2. F at a, where a is equal to 0. So 2 to the power of 0 is gonna be 1, plus 2 to the power of at x equal to 1, which is going to be 2 to the power of 3, then plus 2, open your bracket, it's going to be 2 to the power of 3 times 0.1 to the power of 2, plus 2 to the power of 3, 0.2 to the power of 2, plus blah 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 blah, till you reach 2 to the power of 3, 0.9 to the power of 2, close your brackets, and then you will have your right answer. If I were in your shoe, I will start writing the h, then the rho, then I will state the function, which is f of x. I will write the rho, try to substitute in it this way, and I will leave the final substitution till the end of my time. If I have extra time, I will do it. If not, I will stop right here. And you will miss 1 mark, but the main steps are okay, everything is okay. You translated the message for me that you really understand how to go through it, so you will have a good mark on this problem. It's really very simple, you don't have to think about it, it's really very easy problem. Second problem, he wants you to determine the values of z to the power of 5 plus 32 equal to 0, which is really also a very simple problem. It's asking you about the complex plan. The problem is really very simple. All I have to do is to memorize. You will have to memorize the Cartesian, the Euler, and the polar forms of any complex number, and it's going to be an easy problem to solve. Here, first of all, I will have to memorize that z, if I want to take nth derivative for a certain number, it's going to be easy to have it on behalf of r or theta. It's going to be r to the power of 1 over n. Then